written stories, and searched for discoveries that would carry their names across the centuries. Imagine if you were the one to find a new planet, a hidden world no one had seen before. Your name could be etched forever in the history of science. But sometimes that desire to find something leads us astray. In today's journey, we'll uncover the strange story of a planet that many astronomers swore they had seen a planet closer to the Sun than Mercury. They called it Vulcan. It was reported dozens of times, celebrated as a breakthrough, and even awarded official recognition. The only problem, this planet never existed. To understand how this mystery began, we need to step back to the mid-19th century. In 1846, Urbain Le Verrier, a French mathematician and astronomer, achieved something extraordinary. By carefully studying the motion of Uranus, he noticed it wasn't behaving quite as Newton's laws predicted. The planet's orbit seemed slightly off, as though an unseen force were tugging on it. Le Verrier reasoned that only one explanation fit: another planet further out must be disturbing Uranus's path. Using nothing but mathematics, he calculated exactly where this invisible world should be. When his colleague Johann Galle turned a telescope to that spot, Neptune was discovered within an hour. It was a triumph that electrified the scientific community. Le Verrier had predicted the existence of a planet using pure theory, and he had been right. Naturally, when a few years later he applied the same reasoning to Mercury and suggested another hidden planet might exist, people were eager to believe him. But the idea of an inner planet wasn't new. As far back as 1601, German astronomer Christoph Scheiner had described seeing a dark spot cross the Sun. He thought it might be a new planet, though in reality he was almost certainly observing a sunspot. Over the centuries, others made similar claims. In 1818, Kapil Loft; in 1819, Franz von Gruithuisen; and throughout the 1820s, Johann Pastorff all reported strange dark objects moving across the solar disk. Pastorff insisted he had seen the object a dozen times. By the mid-1800s, the idea had enough momentum that a name was suggested: Vulcan, after the Roman god of fire and metalwork. It was an apt choice. Mercury already reached searing temperatures of over 400 degrees Celsius. Any world closer to the Sun would be hotter still, a planet forged in fire. The turning point came when Le Verrier was asked to examine Mercury's orbit. Using Newton's laws, he calculated the path Mercury should take. But when astronomers compared his predictions with actual observations, something didn't add up. Mercury's orbit shifted slightly, just 45 arcseconds per century, a minuscule amount, but enough to show something was wrong. Le Verrier checked his work again in 1859 using more precise data. The discrepancy persisted. Convinced his mathematics were sound, he concluded that Mercury must be influenced by another body, perhaps a planet, orbiting even closer to the Sun. Given his reputation after Neptune, the scientific world rallied behind him. Vulcan seemed more real than ever. That same year, a French amateur astronomer named Edmond Lescarbault made a claim that seemed to confirm it. In December 1859, using modest instruments in his homemade observatory, he observed a small dark object passing across the Sun. Excited, he wrote to Le Verrier. Le Verrier, intrigued, travelled unannounced to Lescarbault's home to investigate. He questioned the physician, closely examined his notes, and satisfied with the account, declared that Vulcan had been discovered. The announcement was met with great enthusiasm. Lescarbault was awarded the Légion d'honneur, France's highest merit, and invited to present his findings before distinguished scholars. At last the mysterious planet had a face, a name, and a discoverer, or so it seemed. If Vulcan really orbited the Sun, it should have been easy to predict its transits. Le Verrier calculated its supposed orbit about 21 million kilometers from the Sun, completing one revolution every 19 days. In theory, astronomers could mark the calendar and watch for it to reappear. But when they tried, Vulcan failed to show up. Other astronomers scoured the skies, some even claiming to find evidence of it in old records. Yet sightings were inconsistent, vague, and impossible to replicate. The French astronomer Emmanuel Liais provided perhaps the strongest challenge. He claimed to have been observing the sun at the very same moment as Lescarbault, using a more powerful telescope, and saw nothing. Still, the legend of Vulcan persisted. As late as 1878, two respected astronomers independently reported seeing a reddish object near the sun during a solar eclipse. Their accounts matched in detail. Surely, Vulcan must be real, yet once again, no one else could confirm it. In science, truth requires repeatability, and Vulcan stubbornly refused to return. The mystery lingered for decades until Albert Einstein offered a radical new perspective. By 1915, he had developed the general theory of relativity, a model of gravity that went beyond Newton's laws. Newton's equations worked well in most situations, but they broke down near massive bodies like the sun. Einstein's equations, which described space itself as curved by mass, predicted exactly the strange shift in Mercury's orbit without the need for any hidden planet. Under relativity, Vulcan couldn't exist. If a planet were really there, Mercury's orbit would no longer match Einstein's predictions. And when those predictions were tested most famously during the 1919 Eddington expedition, they held true. With that, Vulcan's case collapsed. So what can we learn from this story? Vulcan is a powerful reminder of human bias. When we want to believe something, we sometimes see it, even if it isn't there. Astronomers looked so hard for Vulcan that they convinced themselves of its presence again and again, but always in different ways, never in a repeatable pattern. Science advances not by clinging to ideas, but by testing them, questioning them, and letting evidence lead the way. As Einstein showed, sometimes the answer lies not in searching harder, but in rethinking the question. The phantom planet Vulcan was nothing more than an illusion, a product of ambition, error, and the limits of old physics. It was replaced by Einstein's relativity, which remains the foundation of modern physics, at least until a new theory surpasses it. We may never discover a planet ourselves, but we can still explore the mysteries of the universe together. And sometimes, those mysteries even sit on our desks. For example, a globe of Jupiter turning gently without wires, or batteries powered by light and magnetism. It's a reminder that the cosmos is always within reach. Thank you for joining us on this journey. If you'd like to hear about another hypothetical world, one that hasn't been disproven, let's dive into the mystery of Planet 9 in our next video. Until then, all the best and keep looking up.